Everyone, welcome to our webinar today. The title of our session today is how to streamline concrete structural projects in a BIM environment. My name is Farshad Purshag. I am the Solution Technical Manager for GRAITEC US and Canada. Let's go on with our slides. Okay, so first of all, I would like to give you an overview of what kind of BIM workflow for concrete structures we have in Advanced Design. So Advanced Design is a fully interoperable solution with Autodesk Revit. So you can actually transfer all of your models, the geometry, material, and even the loads directly from your Revit project, structure project to Advanced Design and perform your structural analysis, code checks, as well doing the rebar detailing in Advanced Design. So our BIM workflow for Advanced Design is actually best in class, so it's very easy to use. So we are going to be using the specific GTCX format of GRAITEC to actually export and import our models from Revit. So you will be adding to your productivity and efficiency in your projects, because you just need to model the project geometry once, possibly in Revit, and then directly send it inside Advanced Design. Although it's also possible to start your project directly in Advanced Design and then send it back to Revit, as you see here. So workflow is very flexible. So you can always import, export, and also synchronize your models between Advanced Design and Revit. So as you see here, we have the synchronization window for our AD2 Revit tool. So you can actually see all of the changes that have been done either in Advanced Design or in Revit while you are importing your project. And then you can actually decide if you want to accept those changes or ignore them. So in terms of like very large projects, that's going to be very helpful to organize your changes and import your model more efficiently. And as you see here, our management or synchronization management tool can also control individual members. So you can actually accept some of the changes in our synchronization window and ignore some of them. So it's going to give you the full control of your model import. So as you see here in this graph, there are several ways of using this workflow. So one way is you can actually start from Revit and send your model through GTCX format into Advanced Design. You can, in Advanced Design, you can apply your loads and perform your analysis, code checks, etc. And after the analysis part is performed and done, then you can send it back again through the GTCX into your Revit model. And this will include all of the geometry, material, sections, even the loads. And in terms of exporting from Advanced Design to Revit, you will see that we can also export like things like rebar areas based on the design code, as well internal forces, etc., etc. So the workflow will be like that. Or the other way is like you can start directly from Advanced Design. In case you don't have the model in Revit, you can start from Advanced Design, and after that you can send it directly to Revit. So as you see here in Advanced Design, we have a BIM tab that you can use the tools there to either import, export, or synchronize your models through other Autodesk environment like Revit, which in this case it is the subject of our webinar today, but we have also the same workflow for Advanced Steel. So now let's switch to our Revit and Advanced Design solutions. So then I will show you live how you can actually perform this action and how you can benefit this transfer or BIM workflow in your concrete projects. Okay, I have opened the concrete project in Autodesk Revit. So as you see in this project, I have different elements. So as you see, I have foundations, columns, beams, slabs, and even we have shear walls, as you see there. And as well as you see, I have some loads already applied to my Revit model. So we can actually start by exporting this model directly inside Advanced Design, which the process is actually very simple. So I will go to our Power Pack tool there, and as you see here, we have a Beam Connect tool that you can export, import, and synchronize your models through Revit and send them to Advanced Design. So in this case, I'm going to be exporting my model. So we click on Export. As you see here, we have some parameters here that we can define, for example, types of loads that we want to export to Advanced Design. Also here we have an option that you can select, and after export, it's going to be automatically opening the Advanced Design. In this case, I will just keep everything as default, and I click OK. So here, as you see, I have created a webinar folder here, and I will save my GTCX file with the name of Office in this folder. So we click Save. And now, as you see, it's going to be starting our exporting. So if you want to do some mapping, you can do it here. Actually, in this case, I don't need to do any mapping. It will be automatically, the sections will be recognized automatically here. So I will click No. And now we are going to be actually starting our export. So all of the elements, as you see here, are being exported. If you want to check a report, you can always click Yes here, and it's going to show you a report, as you see here, what kind of elements have been exported and into which folder and file. So I will click on Close this. And now we will open Advanced Design and start by importing our model into Advanced Design. Okay, so now I have opened Advanced Design. So this is actually the first window of Advanced Design. So just go briefly going over the first page. So here you can start a new project directly inside Advanced Design, open the previous projects. Beam import is the option that we are going to be using to import our model inside Advanced Design. And here also I have my configuration. So actually here I can decide on the language of interface and as well the codes that we are going to be using to apply our loads, seismic, climatic, also to perform our reinforced concrete design. Just to let you know, we also have the United States codes here. So as you see, the ASC, ACI, and AIC for steel, and as well NDS for timber, all of them are existing in Advanced Design. So in this case, I can continue with Canadian code. So we click Canada, and I will change my language to English. And we will be having all of the Canadian codes by selected by default. So we click OK. And now I will click on Beam Import. And as you see here, I have my Office project there. You click on that and click Open. So now Advanced Design is reading all of the information from the GTCX file and importing my model. So there you go. The model is imported inside Advanced Design. So here you can have some project settings, as you see there. So for example, you can define project name and etc. This can be later on used or imported inside your reports. So in this case, I will just ignore it. And now if I rotate my model here, I will deactivate my grid, and there you go. So you see all of the elements, even the foundations, are going to be imported as rigid supports, walls, beams, and columns, slabs, and even my openings that I had in my Revit model will be imported automatically. And beside that, all of my loads also will be imported. So as you see here, I have the same loads that we have applied in Revit. So obviously, you can also do modifications here, change the section sizes in Advanced Design. So it's actually very simple. The modeling, even directly inside Advanced Design, is very simple. So we always follow a a grid line, as you see here, to help me with modeling. And if I want to modify some of my members here, or even add some elements, you see, it's very simple to create models in advanced design. It's just by clicking. Now I have defined actually a 2D frame with concrete members there. So you can always start by modeling like that, so it doesn't matter as long as you are following your snap points. And all of the snap points are also can be modified in advanced design. So I will just delete these elements. The other important part in advanced design is actually our properties of our elements. So if I select an element, in this case column, all of the properties of that column will be imported automatically from advanced design. So the material section and other properties also can be defined here. So the properties regarding the concrete design can be also modified here. The other thing is in advanced design we also cover like all of the units standard units that we have. So in this case you see I'm in inches, but if you can just double click there, and here I can directly go and select my default, which is going to be metric. Okay, so we validate, and there you go. Now we are going to be in metric units. So in terms of adding ports to your element, to your project in advanced design, it is again very simple. So here we have all of the supports that we would need in your model to add. Well, in this case, because it is the project is coming from Revit, you don't need to apply supports. You have them all here. But in any case, if you want to add a support to your model, let's say if I have a column like that, here we have different types of supports. So the point supports, linear supports, and we have also planar supports. So in this case, for example, if I want to add a support, you just click there, click at the bottom of the column, and there you go. You can add your support. So this is going to be like how you can actually do model. There are tons of modeling tools in advanced design that you can use to modify your model. In this webinar, we won't go much more into detail there. So because the point of this webinar is mostly concrete design. So what I'm going to do now, I can actually deactivate my work plane. I have some loads already applied here. In advanced design also you can add different types of loads here. So dead loads, live loads, snow, wind, seismic. These three are going to be actually created automatically. So we have a specific climatic load generators to generate specific loads on your structure. And also we have other types of loads like dynamic loads and crane loads, pushover, etc., etc. So for this project, I will just keep my dead loads here. So you can just go on and delete the other ones. So you just right click on the load and you can just delete them. There you go. And the other nice thing about advanced design is you have all of the objects in your model listed here in the project browser. So for example, I can go here. As you see, my structure is organized like based on levels. And as well, like if I go and open each level, level 2, you see I have my beams and slabs, etc., etc. So this is also is very helpful. That it's going to be helpful for you to manage your model much more easier. So here from these lists, you can always hide some stuff. You see here, display them. Even you can select some stuff, some members, etc., directly from your structure here. And same thing for the loads. So I have all of my loads as well listed here. So for example, if you want to select that load, you can go there and all of the loads are listed here. Although you can also select the loads by just clicking on them. And as you see here, similar to members, the load properties as well, when you select them, is going to be displayed here. So in Z direction, -2 kilonewton that we are applying currently to that structure. So to perform a concrete design in advanced design, we will need to define some combinations. So in advanced design, we have automatic load combination generator based on the codes. So you can just go there And now I can click on Simplified Combo. If you want to change the importance category, you can change there. So we will leave it as is and click on Generate. So as you see, it's automatically creating all of the load combinations that they are related to my load cases. So in this case, I have very less because I have defined just one load case. But if you have several load cases, Advanced Design will automatically generate all of the load combinations and factors. So we click OK. And now we are actually ready to run this structure. So we can click on Analysis and click on RC Calculation. Okay, and click OK. So now it's going to start my analysis. So there are some warnings in this model, so I will just ignore them and click Yes. And now actually Advanced Design will start meshing the model. So you see the mesh of the structure. And actually the analysis now is performed, as you see there, and I have my results there. So first type of results that we can have here is going to be like my deformation. So displacements, you click here, and this is going to be the deformation of that structure. You can also select which load case or load combination you want to display that specific deformation, so you have control on there. The other type of results that we have are actually the forces inside the elements. So I selected forces, and here I'm going to select my linear elements, and now I can access all of the internal forces, axial, shear, and moment in 3 directions. So for example, if I go to axial, click there, and here I can see the axial force inside my columns and elements. You can actually activate the values on diagrams. So now I can actually see the values on diagrams, and as well you can see the color-coded map here in case if you want to see the other values. So same thing for example, for my moment. So I can simply go there and check my moment in every direction, as you see there. So MX and Y moments, and also the other type of moments. We also have the results, finite element results for my planar elements here. So you can simply switch to planar, and here I can have the forces inside the elements. And if I want to see the stresses, you go to stresses, and here you can see all of the related stresses in your planar elements. So for example, if I want to check for the S1 top, click there, and this is going to be the stress distribution in my planar elements, as you see there. So these are like some simple finite element results that you can see here. So we have different also options to display all of these values. So you see, if I zoom in, I can also see the values. We also have here some results curve that it's going to provide you with 2D graphs in case if you want to see more detailed results on any type of actually internal force or stresses. So beside our finite element results now, because we have performed concrete analysis, here I have concrete results. So basically I can consult the reinforcement that's been calculated for my elements. So for example, for linear elements, I can go there, and from here I can check the required rebar area, longitudinal and transverse. So for example, if I select the AY, which is going to be longitudinal rebars in local Y direction, click there, and here I can see the value of longitudinal rebar needed for that specific column. And as you see here, the values are based on square millimeters. As well, I can see the other direction. So if you want to change the scale of the diagram, you have the control here. You make them smaller, and here it's going to give you the required rebars. So well, here, like basically, we have performed our concrete design. Now we have access to the full rebar areas in my model. But in advanced design, we can even go more into deep, like if I want to detail as well my concrete column in advanced design, it is possible. And it's actually one of the main benefits of advanced design. So in this case, I will just select this column and open it in my design modules. So design modules are the tools in advanced design that it's going to help you with your actually rebar detailing and code check and design of that specific member. So in this case, as you see, I have opened my column in advanced design. So all of the forces that are being applied to that column or specific element will be imported directly. So you have your moment, shear, and axial forces on that column. Here I have an elevation view. Here we have the 3D view of that column, and here we have the section of the column. So here, actually, if I can, I can directly click on calculate. And there you go. I can perform my calculation and rebar detailing on that specific column. So advanced design will automatically add all of the stirrups or main rebars inside the column. You can actually change the view of this section down there. So I can actually change and see what kind of rebars we have there. The other nice thing is you can actually just hover your mouse on that specific rebar and double click. And then a window will be opened and advanced design will show you the properties of that rebar, the dimensioning, the diameter, etc. And if you want to modify those properties regarding that rebar, you can simply modify all of the properties from this window and click apply. So you can actually customize also the rebar detailing that advanced design have created for you. The other nice thing here is I have also my design results. So here you see the real reinforcement and theoretical and the ratio here. And here it's going to show you on based on which load combination it is calculating your rebars. So there are also other options here. For example, you can go to our design settings. So you can, if you want, you can actually modify all of the values there, like reinforced concrete, concrete covers, etc., from those values or from those options. Beside that, I also have the interaction curves because we are talking about a column here. So this is the interaction curve of moment and axial force, as you see here. We can see the diagrams of applied forces to that column. And the other very interesting part here is advanced design is also able to create the full drawing of the column and rebars for you here, as you see. So this is the elevation. I have my sections in two cuts. And as well here, I have my rebar schedule, which, as you know, like sometimes it can be time consuming to create it, but advanced design is able to create that automatically for your element. So this was like about for our column element, but in advanced design we can do actually the same procedure for also beams, foundations, slabs, and even the walls. So for example, if I close this element here and go back to my main model, I can actually select also a foundation and the rebar detailing on that foundation. So you just need to right click and open it in our design modules. So there you go. I have the foundation. We have the dimensions there, applied force. We also have the soil definition here. As you see here, you can define different types of soil for your foundation design. It's going to be actually here from the soil profile. So you can define the thickness of the layer, the material type, etc., and advanced design will consider that in the design of that foundation. So simply by clicking on calculate, there you go. It's going to calculate all of the required rebars inside the foundation. If there are some errors, so in this case I have an error for SLS condition for the settlement. So it will also let us know if there are some errors in the design. Also here I can see the analysis diagram. For advanced design, we can check the stability diagram. So this is going to be the overturning check, stability check for our foundation, and also the value of stress distribution under the foundation. And finally, if I click on interactive drawing, you will see that I have my drawings for my foundations, and as well as you see here, the bar schedule will be displayed here. So now if I go back to my main model here, I would also like to show you our slab design actually in advanced design, because in advanced design we have two methods to perform your slab design. One is going to be based on the finite element results, and the other one is going to be based on the strip method. So we have actually both of them in advanced design. So in order to perform that, we can simply select the slab. So in this case, for example, I can select this slab, right click, and I'm going to be opening it with my design modules. There you go. So this is going to be my slab, and as you see, I have my all of the opening also imported in design modules. So now we have actually two options. The first option is the reinforcement design will be based on finite element method, and we also have another option which is called the strip method. So we have both of them. So in this case, I will use strip method because this is mostly used in North America. So we go to strip method. And now we will have control on our strips. So if I go to strips, actually directly create my strips manually. So we have options here that you can create the middle and column strips from here, or support strips. Also, we have an automatic tool here that it can create your strips directly by clicking there, which I'm going to be using this. And now, as you see, it's going to automatically create all of the required strips for me for this slab. So now that we have that strip, we can actually click on calculate. So we can calculate our rebars. Now, if I go back to my model, you will see that the rebars have been placed automatically for my slab here. So again, if you have some warnings or errors, it will show up here, so you can actually modify that. The other type of results that I can get here, for example, I can check my minor or major direction reinforcements. So for example, we can go here, and now I can actually select what type of forces I want to see for each strip. So it's going to show me all of them. So we can go to also major. So this is going to be my moment on each strip separately. So we can actually select all of the results that we want to consult to perform our strip design. So as you see here, you can use all of those values. Either way, Advanced Design has already included those calculations to define your rebars. So here we can see the reinforcement diagram. So the required and theoretical and real ones. You can check your reinforcement zones. So if you want to define extra zones for your reinforcement, you can define them from here. So by default, it's going to be covering all of the slab, but using this tool, you can actually add extra layers, etc., etc. We have the reinforcement cage displayed here, zones and cage here, and finally, here, as you see, we can access our drawings. So this is going to be the drawing created for my slab. So as you see, Advanced Design is a very useful tool to perform your concrete design and also rebar placement directly in the same software. And beside that, you will have all of your finite element results coming from your external loads from Advanced Design. So also Advanced Design can generate reports for your design. So each element that you select here and you perform your design on that, for example, if I go back and open my column here again, so if you want to get a design reports, we have that option here. So as you see here, we have the generate report. So you can click on that, and it's going to create the report required for design of this specific element. So if I bring that here, so this is going to be the full report of design of that concrete column, as you see here. So you have access to all of the details and required parameters that advanced design is using to generate that specific rebars and design. Okay, so I will close my column here. Now, because this webinar is about like a concrete workflow, so now I'm going to show you how we can actually send back our model, which is created now, back to my Revit and synchronize my elements. Okay, so we can see more stuff there. So just to show you the changes and how the changes can be imported inside Revit using the synchronization, I will just go back to my model and I will modify the section of this column. So let's say this column needs to be changed because of the design issues. So it's actually, if I access the section of that column, so I see it's 60 by 60. So in this case, I will change it to, let's say, 80 by 80. And click OK. So now I have a larger column. Let's select that again. So now we have a larger column. Now what we can do is we can perform our analysis again. RC calculation. So we will have our new design based on the new section. Okay, great. Now what we are going to be doing is exporting our model back inside Revit, so using the synchronization option. So similar to Revit, also in Advanced Design, we have a BIM tool. We go there, and here I have my GRAITEC BIM tool. In this case, we are going to be exporting our model inside Revit, so I will click on Export. And here into the same folder, I will just name another file, which is going to be Office. Let's name it Office to Revit. And click Save. Now the model is exported. And now I can actually go back to my Revit model. So you click here, I have it open. So this is the original model that I had in Revit, and we exported to Advanced Design. Now I will import that model directly inside this model, but I'm using the synchronization because I want to also import my changes. So same thing here, we go to BIM Connect. In this case, I will use synchronization. So click there. We don't need a material mapping. And now what's going to happen is you will see a new window, which is called our synchronization window. So this is the window that we can control all of the imported parameters from Advanced Design. So simply click on Open. And now I will call in my exported model from Advanced Design, which was Office to Revit. Click Open. So as you see here, we can have a list of changes here that we have. As well, you can see that we are importing our finite element results and also our reinforcement inside Revit, which is very important because you can also perform the checks directly inside Revit. So as you see here, we can filter our changes here based on the type or attributes. So if I put a search here, like I can just search for the type of section which is changed, and here you can see that it's going to be filtering it, and I see here that I have a linear element which is a column and it is modified. So this is the same column that, if you remember, I modified in Advanced Design. So if you want to see more detail, you can click here, and in the parameters it's going to actually show you what's happening to that column. So it's going to tell me that it was a 60 centimeter column, and now in the new model, new import, it has been changed to 80 centimeters. So as you see, it's automatically detecting my changes. So in this case, if you want to accept this change, you can just go there and click Accept, and this change will be accepted, and it's going to be imported to your Revit model. So we click Accept and Apply. Yes, we confirm it. If you want to have a report, you can do it from here, but in this case, no. And now it's going to be applying my changes to my Revit model. Okay, now we click OK. And now if I zoom in onto that column, you see that that column has changed based on the model that I have imported from Advanced Design. So this is how actually our synchronization works. So, and as I mentioned earlier, it works for all of the elements. So if you have any changes anywhere in your model, it's going to warn you, and then you can decide if you want to include it in your Revit model or no. So as I mentioned earlier, the also like one of the important benefits of our GRAITEC transfer mechanism is also you can actually import your internal forces and rebar areas directly from Advanced Design, from your finite element analysis. So, and actually I have them here. So to see that, we can go to our analysis tab here and results manager. So here you see I have two sets of new results that they have been updated. So I can actually click close and go back to my results explorer, and actually we can see those values here. So for example, I can select my analysis results. You can select your load, forces, let's say actual, and apply. As you see here, I see my actual forces in all of the elements which are directly coming from Advanced Design. And I have them in Revit. So you can actually see them also for a moment, etc., etc. So again, this is very useful because if for any reason you want to also perform your design, concrete design inside Revit, you can use our power packs that we have there. And using those power packs, you can directly perform reinforcement, design, and code checks directly inside Revit. So for example, if I want to show that to you, we can simply go to our Power Pack Design tool, okay? And here I can read in all of my results. So I'm going to be importing my results, basically the up-to-date ones that we just performed. Click OK. Okay. So now we are reading in all of our forces inside the elements. And now I can directly perform rebar detailing, for example, on every element. So if I select this column, go to Power Pack Design and click on Calculate. Now in Revit, I am performing my concrete design. And as you see here, based on my forces coming from Advanced Design, our Power Pack will automatically generate all of my rebars. And the nice thing here is, again, you can also ask for reports from here. This check mark is showing me that the member is passing, so it's going to be enough, and calculation is okay. So this is also a very nice tool in case if you want to use it directly inside Revit. And we have this module, as I mentioned, we have 4 columns. I can also perform design for foundations. So you just click on foundations, you go to Power Pack Design and click on Calculate. And there you go. You will have the rebar placement for your foundation. So as you see here, you can fully also design your structure in Revit using our Power Packs, and obviously based on the results that they are coming in from Advanced Design. The other very interesting tool that we have here in our Power Pack, it's actually rebar placement for your slabs. Okay, so if you remember, we also brought in our rebar area from Advanced Design, which we can use that calculation to also apply our rebars to our slabs. So in this case, I can use our Power Packs again. So you just select the slab, go to Power Pack Detailing, and here I have the slab tool. I will click on Edit Window. So now we are going to be opening our slab directly in a separate window, which is going to be mostly based on our rebar areas. Okay, there you go. I have the window. This is my slab. I can see different layers and areas that we need, for example, top or bottom. And this is the required rebar area at the bottom layer in X direction. You can also change it to Y direction, as you see here. And now I can directly perform my rebar placement in Revit using this tool, and it's going to be based on the values that I have here. So that's going to be very useful. So to do that, we can actually add different zones. So you can actually put your rebars based on different zones, or you can actually select the full slab. So in that case, I will just select the full slab, and I will put my rebars in both directions. So you click there, and now I'm going to be selecting my zone. So in this case, I will select full slab. There you go. You just need to click on the corners. And now I have the control to put my rebars. And this is going to be dynamic fully. So for example, I can start my first rebar, let's say from 500 millimeters. And now I can start by adding or changing the distancing based on the rebar area that I require. And as you see, it's fully dynamic. So when I'm putting my rebars farther away, because I have less rebars, less area of steel, as you see, I'm not covering my theoretical rebars. But when I'm putting them closer, you see, at some point, I'm covering it fully. So here, I'm going to decide that my spacing is 600 millimeters, and I will click. And now I've added my that direction of rebars, and now we're going to be working in this direction. Okay. So basically, same scenario here. I can start with, let's say, 300 millimeters, and again, based on my finite element rebars, I can put my rebars in a very economical way that I'm not using high value of steel. So that's it. So I'm covering it now. Click OK. And now this rebar will be applied to my Revit. So there you go. And if I click OK, go back to Revit. So it's generating, and there you go. I have my rebars created for my bottom layer of that slab. So we can actually perform the same scenario. So just here, I will hide my diagrams. So it's going to be more clear, as you see here, the rebars. And the good thing is, our tool here, the Power Pack, will automatically detect all of the openings that you have here. So you can actually perform the same scenario for the top rebar. We also have other tools here in our Power Pack, which is called in Power Pack Detailing, that you can generate also all of your drawings, bar schedules, section cuts, etc., in our Power Pack for Revit. Okay, so that was basically it about our workflow for concrete and performing concrete design in advanced design using advanced design tools, and also we also talked about a bit our tools that we have for concrete design actually directly inside Revit. So let's go back to our slides. Okay, so thanks for your presence today, and I hope you have you got an idea of the workflow between advanced design and Revit for concrete structures. So you can always, if you have any questions, you can always send your questions to our support email. So support.us@graitec.com and support.canada@graitec.com. As well, if you want to have a trial just to try our solutions, you can just send us an email here, and we are going to be helping you to get your trial version. So now it's the question and answering time. So if you have any questions, please just type the question in the chat tool of the platform, and I'm going to be answering all of them right now. And in case, again, if you will have other questions later on, don't hesitate to contact us through our technical support. Thank you very much.